Assalamu alaikum students. Today's topic is going to be about terminal velocity. Let us read about the terminal velocity and what is its definition. The maximum velocity that is attained and maintained by an object while falling through a resistive medium is called a terminal velocity Vt. Let's assume that this is a spherical body which is falling under the action of gravity. That's why acceleration is taken to be g, and its velocity at the moment is 0 meter per second. Now, as the body falls down with a velocity, after some time we'll see that the velocity has become constant, and as the velocity becomes constant the acceleration will be equal to 0 meter per second square. Now in this situation, this constant velocity is known as vt, or terminal velocity. Now at this velocity the upward force, which is a drag force, which is 6 pi eta r vt, is equal to the weight of that body, which is Fg is equal to W is equal to mg, which is the weight of that body. Now if these two forces cancel out each other like this, then the acceleration in this case will be equal to 0. That means there is no net force. When the net force on an object is 0, then the acceleration terminates. We say that the object has reached its terminal speed. If we are concerned with the direction of downward falling object, we say that the object has reached its terminal velocity Vt. We will be concerned with the terminal velocity for the simplest case, that is the uniform density spherical object falling through a consistent medium as shown in figure. Now in this case, we have shown that the body was falling under the action of gravity in a viscosity of eta, and there was upward thrust, that means Fd, which have the value of 6 pi eta rvt. Now in this case, the Newton's law for all objects, whether freely falling or falling in the presence of resistive force, the acceleration, however, is are quite different due to difference in net force. In vacuum, the net force is the weight because it is the only thing which is present over there. It is the only force. However, in the presence of the air resistance, the net force is less than the weight. It is the weight minus the drag force. How? Let's say this is the body and it is falling in the direction of gravity with no air present. So only force which is present over there is mg. But as soon as air particles are involved, they will push this mass in the upward direction because of drag force. So the total force by which this body will move downwards will be equal to F is equal to ma, which is applied force on the direction of gravity, which will be equal to mg, the weight of the body, minus the drag force. That means it is moving in this way, but the weight is a little bit higher than the drag force. But drag force also plays an important part in this one. So that is why we have said the net force, which is F is equal to ma, is equal to Fg, which is the gravitational force of weight, minus the Fd, that means the drag force. Here the net force is ma, the drag force is 6 pi eta r vt, or we can say v, and Fg is equal to weight is equal to mg. Now if we put in the values, we get ma is equal to mg minus 6 pi eta r vt, or v. Here Fg and Fd are equal. Now in this situation, the velocity becomes the terminal velocity, then the net force is equal to 0. Then the acceleration will be equal to 0 because their velocity has reached its terminal velocity, and we remember that at terminal velocity the velocity is constant. That is why the acceleration is equal to 0, and Vt is basically achieved in this equation. The equation is mo because there is no acceleration now, acceleration is 0. So instead of this a, we are putting 0, is equal to mg minus 6 pi eta r vt. We take multiplication of 0 and m to be 0 is equal to mg minus 6 pi eta r vt. From that we can derive the equation of vt by taking the negative sign to the other side. It will be 6 pi eta r vt is equal to mg. And if we want to calculate the value of vt, taking all of the other components to the other side, it will be vt is equal to mg divided by 6 pi eta r. But we over here we know the value of g, which is 9.8 meter per second. We know the radius of the spherical object. We know the viscosity of the body through which it was falling through. We know the values of 6 pi as well. But the only thing which we don't know is the mass of that object which is falling, or the spherical object which is falling. For that reason, we are going to solve it for a uniform density of a spherical body, or sphere of a uniform density is given by m is equal to rho into v, where rho is representing the density and V, capital V, is representing the volume in this case. Now, the volume of the sphere as it is given by V is equal to 4 over 3 pi r cube, where r is the radius of that sphere. So putting this value of V, which is over here in this equation, let's say equation number 1, putting the values of V from equation 2 in equation 1, we get m is equal to 4 over 3 pi r cube. Putting this value of m in the first equation of the terminal velocity, we get, putting the values of equation 3, which is of mass, in the terminal velocity, what do you get? Vt. Instead of m, now we are putting down 4 over 3 pi r cube into rho and g divided by 6 pi eta r. And this is the new equation of the terminal velocity. Let us solve it even more. So this r and this r cube basically cancel out. So r square is on the top, and this pi basically cancel out with this pi as well. So the things which are left now are Vt is equal to 4 r square rho g divided by 3 into 6 eta. Now if we solve it in more, so this 3 into 6 is 18, and if on the top it is 4 r square rho into g divided by 18 eta. So we can solve it even more, that 2 2s are 4 and 2 9s are 18. We can say now the new equation has become that rearranging Vt is equal to 2 r square g rho divided by 9 eta. Now this equation is basically the terminal velocity, which is represented by Vt is equal to 2 r square g rho over 9 eta. Now the equation represents the terminal velocity of a spherical object, the density rho and the radius r falling with the acceleration due to gravity g in the medium of coefficient of viscosity eta. As the terminal velocity depends upon the size, shape and orientation of the object, it also depends upon the coefficient of viscosity, medium and speed. Therefore, there is no single speed of terminal velocity. Now that is why we are taking the terminal velocity of different objects recently. Inshallah, we'll meet again. I hope you enjoyed the topic. Allah Hafiz. Bye bye.